Welcome back to MH Science. In this video, we will discover the basic principles of radar systems. Radar is used to detect objects in the sky. It is used in many applications, such as military, air traffic control, marine, astronomy, weather mapping, and terrain mapping. Radar stands for radio detection and ranging. The main components of radar are the transmitter and receiver antennas. If we have an antenna that is connected to an oscillating current source, the electrical charge will oscillate along the antenna. This oscillating charge will produce electromagnetic waves that propagate through the air. Radar has many types of antenna designs. The transmitter antenna is commonly designed to propagate waves into a specific area and direction. Electromagnetic waves propagate at the speed of light, which is 300 million meters per second. Electromagnetic waves have a characteristic that allows them to reflect back to their source when they hit a solid object. So, if the wave hits an aircraft, it will reflect back to the radar. The receiver antenna will pick up the reflected waves and plot the signals. By calculating the time taken for the wave to travel between transmission and return to the receiver, the distance to the aircraft can be determined. For example, let's say the distance from the radar to the aircraft is d. Here, we can see the wave propagate to the aircraft in 0.001 seconds and reflect back to the receiver in the same amount of time. So, the receiver calculates the total time between transmission and reception is 0.002 seconds. The total distance the wave travels to the aircraft and reflects back to the receiver is 2 times the distance d. We already know that the speed of the wave is 300 million meters per second. Now, we can find the distance d using the speed equation. By replacing the values, we find that d is 300 kilometers. So, this is how radar detects the presence of the aircraft and its location. The speed of the aircraft can also be determined by transmitting the next wave pulse. Let's say the first wave is transmitted at time 0. And the receiver detects the aircraft after 0.002 seconds, with the distance calculated to be 300 kilometers. Here, we can see that the aircraft is moving. Now, 1 second after the first wave is transmitted, the second wave is transmitted. The second wave returns to the radar after 0.001998 seconds. The calculated distance is 299.7 kilometers. By comparing the distance data of the first and second waves, we can calculate the speed of the aircraft. Speed is equal to the difference in distances, divided by the time interval between the first and second waves transmitted, which is 1 second. The speed of the aircraft we obtained is minus 300 meters per second, or 1080 kilometers per hour. The negative value indicates that the aircraft is moving toward the radar. In addition to location and speed, radar is also capable of detecting the size of the aircraft. This is because smaller aircraft reflect smaller waves, while larger aircraft reflect bigger waves. So, that is how radar works to detect the presence, location, speed, and size of an aircraft. That's all for this video. Thank you for watching, and please subscribe to our channel. See you in the next video.